In this video, Henry of Blockworks UK is going to show us how he stabilises this wood to be used as handle materials for other knife makers.
My name's Henry Lee, I'm the owner and operator of Blockworks UK, and I supply stabilised wood to craftspeople and knife makers all over the world. So when the wood comes into me, it's in a variety of states. I get logs, I get billets, and I even get blocks pre-cut. Now, these come at a variety of different moisture contents, which I have to deal with and dry in the oven. And I also have to process down to the specific sizes that are needed and requested by my customers. They come from billets to blocks to even logs. For something like this, it's a billet of curly maple. This will require milling and drying down to 0% moisture to prepare it for the stabilising. When I'm assessing a piece of wood for cutting, I have to look at the grain structure, the grain direction, any interlocking grain, and then base that off my knowledge of the type of wood, how that will react with being milled and how the stresses within the wood will come out when it's dried. So for a slab like this, I'll have to have a look at the end grain and then assess where it's quarter sawn, where it's flat sawn. This then gives me where the best curl is going to be and where the best curl is not going to be, and then that allows me to make an informed decision on where to cut. It does come from Canada. It depends a little bit on the species of maple, because Acer is quite a large species and the native ranges of a lot of the more common Acers are all across North America, down into Europe and across to Siberia. The maple I get comes from three main places, either Canada, the US or the Ukraine, and I do get some bits from the UK as well, although good figured maple tends to be harder to come by. With the maple that I get from the Ukraine, that tends to be softer with a more open grain versus stuff from the Canada and the US which is denser and a tighter grain, which has implications on the stabilising and implementing dyes into the process, all has an effect on the finished product. There seems to be a bit of an industry standard of 30mm as a thickness, although most knife makers can work with 25mm, sometimes 22mm. I always try to provide enough to a wide range of people, so by keeping my blocks standard at 30mm thick gives the opportunity for wire handles, full tang, and even pen turners and other related things. Does help that it's got 3 TPI ripping blade on, so it does just go through anything. I've had 12 inches of rosewood through this before and it's been absolutely fine. So for different bandsaw blades, it's all about the task at hand. For obviously people doing knife making and stuff, they'll require quite a slow bandsaw speed, but with a 24 TPI blade. Because I'm doing wood, that just wouldn't cut, especially on a wood bandsaw that goes at a much higher speed. For most of my things I use a 6 TPI blade, and that gives me quite a good finish straight off the blade. But for larger ripping, dealing with big chunks of wood, I tend to use a 3 TPI bimetal blade, which just gives me a greater chip and dust clearance, and also because you're cutting on less teeth, the speed of the machine stays up, although it does give you a rougher finish. But in larger billets, that'll get sawed off anyway. So when drying wood, there's a range of different temperatures that need to be used. If the wood is quite wet, somewhere between 10 to 25%, you'd want to start the oven at 30 degrees C and have that going for a day, and then slowly increase it to 50 and then 70, 90, and then to 110. So it could take 4 or 5 days to fully dry out a piece. If it's quite a stable wood that is quite dry already, it is then just a few hours at 110 to boil off all the water or get rid of it. With curing the cactus juice, that needs to be done at 93 degrees C. That can be done in the same oven, but you just need to adjust the temperature slightly. For curly maple, the oven tends to run for around 8 hours to get it down to 0%, although there is variation throughout the woods and the sizes as well. If they were small pen blanks, they'd be done much quicker than if they were an 8-inch thick lump. Once they've then finished in the oven, they'll be placed in vacuum chambers to cool and then to stabilize. I know when they're done and ready because of experience, and I'm used to now telling what the wood looks like and how it feels, but I also use moisture meters to test where it is. Most moisture meters won't go down below 5%, so they're a good indicator before that. And then you can use the weight. We basically heat them until constant mass. So you measure or you weigh a few of them and record those weights, and then dry them, and 3 hours later you pull them out, you weigh them again, and you keep doing that until they're not losing any more moisture. Once they are at 0%, they can then take in moisture from the atmosphere. Now, as we're in the northeast of the UK, it's quite wet a lot of the time. So what I do to prevent the taking in of moisture is I'll put them in a vacuum chamber and pull a vacuum, which lets them cool without regaining any moisture. And then once they're cool, they'll then go into the resin to have the optimal stabilizing experience. Once the vacuum has been released, you are then at atmospheric pressure. Now, to speed the process up and to increase the quality of the product, I put it in my pressure pot. So this is a 40-litre pressure pot used for paint mixing usually, but lends itself incredibly well to pressurizing things for resin casting and stabilizing. I removed the lid and removed the lid of my vacuum chamber, and it slides perfectly in, and I can just get it in. That will then sit in there, and the lid goes on, it's clamped up and then pressurized. I try to pressurize at around 75 psi for at least 24 hours, usually 48. One of the modifications that I've made to the pressure pot is the addition of a vacuum hose. Through various fittings and connectors, this will attach to my vacuum pump and can pull a vacuum through my pressure pot. If I seal up this end, I can create a near full vacuum in this pressure pot, exactly like the vacuum chambers, but it's just much bigger. This will then speed up the process because I can run 8 or 9 colours in a single chamber instead of 1 in this chamber. And also it allows me to get a tighter fit on the lid because it's pulling it down, and means I'm not doing lots of changing around, so I can process more. Stabilizing is submerging a thin resin over the entire block or blocks, and then pulling a vacuum, creating a pressure differential, which then forces that resin into the wood. So once the wood is dry and in the chamber, I then release the vacuum and put on a weight. Now, this prevents the wood from rising up because it needs to be submerged. If it does rise up, you then start forcing air back into the wood, which is exactly what you don't want. Stabilizing is the process of removing that air and replacing it with resin. So by having a weight on there, we'll keep it all submerged below the resin and preventing any of that from happening. The wood is all in the chamber, weighted down and dry. It's time for the resin. I use cactus juice, which seems to be an industry standard across the board in both the US and the UK. It's produced over in the States and is very expensive, but that doesn't stop me from using it because it is an excellent product. So the resin that I use is a methacrylate ester over an epoxy resin or a urethane resin. The thing with an epoxy or a urethane resin is they're very thick. They have an A and B mix that you mix together, and then that triggers an exothermic reaction, curing the resin. Now, cactus juice, as it's a chain of methacrylate esters, is a bit different. First, you have to add an activator, which activates the resin, and that is a surfactant, so it lowers the surface tension. Once that's happened, it then can be cured, but you can have it activated resin stored for up to a year before it will start to go off, and it needs heat to actually cure. Occasionally, if you have contaminants in the resin, that can cause flash curing, or if it gets too hot and then there's some form of contaminant as well, but uncontaminated resin won't cure any other way rather than in the oven. One of the good things about cactus juice is you can reuse it. This here is a bit brown. This has been through 3 cycles now of different woods, and out of that you get little particulates of sawdust, little bits of oil as well occasionally. Now, because it's in a very low concentration, it has no effect to the outcome of any future products that I make with it, because any of those wouldn't get into the wood because it is just the resin. If you look at the resin and it's super murky, that means there's way too much in there and it's probably not good to use. But if it's still quite clear, just a bit discoloured, there's no issues, because you need such a high dye concentration for it to actually have an effect on the wood's outcome. After 3 days under vacuum, the pressure is then released. Then you have to leave it to soak. Now, with the soaking, you need that atmospheric pressure to force the resin into the wood, which without the soaking, you'd have a product that is virtually the same as the wood you started with, just a bit wet. Now, once that has soaked, it is then ready for removing and curing. So these pieces here have now gained a lot more resin. They're so much denser than when you started, and they also look a bit wet. Now, this is just from the resin, and this will cure and then will all sand off and it will look like it did when it started. No changes except the density. So I take this out and it goes into my little pot here to dry off a bit and to let the excess resin drip. Now, this means that I can reuse that. It just goes back in. It's only small amounts, but it prevents it from going in the oven and then I have to clean the oven out more often. It's small quantities, but over a long time will add up. It does save me money. The next bit of the process is the curing. The wood from the vacuum chambers goes into the oven at around 93 to 95 degrees C. You can go hotter than that, but you'll get excess bleed out, which is where the resin bleeds out of the wood, and you lose then density. But if it's too cool, it then won't cure, which again isn't good. If the oven starts off too cool and then heats up, that does have an impact, but the cure time will be about an extra 50% longer. So it's best to have the oven hot when you put them in to start that cure. The blocks are cured at around 93 degrees C. This cures the resin but doesn't damage the wood in any way. If the temperature's too high, you can get a lot of bleed out, which is the resin leaving the wood, and also you risk cracking and warping the pieces. There are the odd time when it needs to be high. For example, if you're creating torrefied wood, which is roasted maple, it's quite commonly known as, and also horse chestnut and other related species. Now that the blocks are cured, they're ready to come out the oven and then prepare for the sanding and finishing. So when they come out, they tend to look a little bit rough. So you can't see the figure too well, and occasionally you get colour on here from the racks. Because I'm curing so many different colours, bit of excess resin on the racks like this, but because the wood has been impregnated with the clear resin, it shouldn't affect the end product, it will just be surface. Also, you get this here, which is resin that's cured on the racks and almost fused itself to the wood, and it does just snap off. But you then also, you have the issue of sanding it off, but it's just a resin, you know, it will sand off quite easily. After it's cured, I'll let it cool and then I'll sand it. The sanding is done on a 2x42 belt grinder. Nothing fancy, but gets the job done. So there I just used 3M Cubitron 120 grit just to sand it up, and it removes the rough edges really quickly and gives me a pretty good finish, which then you apply some oil, some wax, some isopropyl alcohol or acetone. That will then give you a really good finish for a photograph. After the blocks have been sanded, I've taken photos and they'll then go up on my Instagram or my website, and then people will see them. They're up there with dimensions and prices, and once they sell, if they sell, they then get packaged up and posted off.
This video is made possible by Multi-Tool Products Europe, Clark Knives and GFS Knife Supplies. GFS Knife Supplies is a small team comprised of Dave, his dad, and his brother. They have been instrumental in giving knife makers a wide range of high quality materials for knife making since 2015, but their industrial roots actually go all the way back to a total of 80 years for all of the team combined. Despite being a small family run business, they actually have the quickest deliveries for all your knife making needs. You need a great selection of knife making belts? They have it. Steel stock for knives? They have tons of them, literally. Sandvik, Lomans, Crucible, and now actually includes British made steel. Need to heat treat them? Get their Rockblade heat kiln. Single phase, so it's easy to install, and because it's available in finance, you'd be able to get your own one today. How about for quenching? Well, they have a great range of selection of rye oil with different quenching speeds, and also the anti-scale coatings available from GFS. Do you need a complete selection of handle materials? They have it all. All the links for this product are in the description, so make sure you check them out. Go ahead and order your knife making bits, and then come back to watch this other video over here, which is another professional knife maker showing us how to make a perfect knife handle. Thanks for watching, and see you on the next video.
Henry Lee. Awesome. Okay, I got it. Next stage.